International Professional Engineer Certification under IPEA, International Professional Engineers Association or Agreement, in which 15 countries, including USA, England, Canada, etc., South Africa, are all members. And our Institution of Engineers of this country is also a permanent member of that body. It is for your information. And here, this is Chartered Engineer Certification issued under Royal Charter 1935, Royal Charter of Institution of Engineers, India. And here is fellow membership of IEI, that is Institution of Engineers India, as I told you, under Royal Charter 1935. And here are certain issues that require talks, discussions every day. I do, and this is, concrete, general, soil, FIDIC, and management, organization, etc., etc., all in some miscellaneous forms. For your information, this is Engineer Suraj Singh, as I showed to you my certifications, and I am this one. Speaking from Bharat, India, for addressing issues of profession to whole world. The scope of this talk is very much professional, and profession means whatever can be implemented based on whatever has been learned. It's very important point that we have to understand. Learning based on education, and then application of what you learn in your field, in your education, you have to apply that, and that application is called professional application. Professional means that something is useful for humanity, for society. That is profession. It's not simple, you can say, imaginary world. It is useful world, or you can say it is a world that results in products or goods. Engineering is actually a field where production is done, direct production or indirect production based on known theories, known material processes or designs, and production that is based on complete theory, which is realized in terms of products. Whatever products we achieve or we gain, that is based on engineering, and therefore it is called engineering product. I have previously involved you people with many talks related to national issues, international issues, talks related to profession, that is my profession is civil engineering. Basically civil engineering, and someone is basically mechanical, electrical, whatever branch of engineering one joins, that is something different. It is, you can say that that is what I mean to say. Individual interest in whichever field, whichever discipline or branch of engineering one joins. I have started my profession from civil engineering, and then I jumped over to construction, and construction is mainly combination of many branches of engineering as well as others. There is no single branch of engineering that can claim it is exclusively meant for construction or for designs. Designs, to some extent, you can say it is purely disciplinary, it is purely engineering professional, because we cannot change, we cannot assume that design can be done in different branches simultaneously, though there can be coordinations of requirements on site. Designs is a different world, and it's not very useful to talk to people, particularly the general people of world, because there is so much complications in this, so many theories are involved, so many processes and formula are involved, evolution of formula, derivation of formula, empirical formula, experience, and all this involved in design world. Design world is a world that you can say sometimes it is perfect and sometimes it is evolutionary. When it is perfect based on experience and you can say proven products, it's something else. But when it is in form of operational research, it is different. Means you have to create something which was never done before, and that is actually, though it's a part of design, it's a part of engineering, yet it is, you can say, something, it pertains to something innovative engineering, you can say, though it's a part of engineering, it's a professional work, nothing exclusive, but something which was never done before. If it's done, it imports attraction of people around the world. So when I talk to you, I talk based on certain points. For example, today is 19 January and I'm talking to you 19 January 2021. I also speak here as written title of this topic. As written the civil field engineering and general designs, contracts, construction organizations, communication, coordination, project quantity, project quality, why should we be behind quality of materials and concrete standards, material and concrete standard work, etc., etc. There's so much in this. Its title, its generalized title, because when I talk to you, I cannot confine myself to one point because all points are related to each other, overlap each other, just like life sometimes overlap with other people. Here, not people, but mental thinking. Again I say thinking because thinking is very important word in life. Education is based on thinking and thinking is based on education. This is two-way. You may have whatever education in your life, but real education you get only when experience that what you learned. If it comes validated or it was just imaginary. Validation of what you learned is very important, and if it's validated, you can say, yes, my education was very well engineered. Your knowledge is engineered when you practically, you by word, by work, by exposure, you come to know what did you learn was really wonderful. Though it could not be understood that time when you studied, you joined university or you joined your educational institution. That time, because everybody remains in the age of 20, 24, 23, 18, 19, and that age you don't have enough experience of life sciences, life commerce, life art, or whatever includes in world. You at that age cannot in general say that I am aware of that part of education in the adolescence or youth age is different. It's meant just to open and develop your mental capacity and a kind of feeding in your mind that your feeding is perfect. That is tested by your examination, how much you could learn. Although nobody is expected to learn 100%, a certain criteria, certain silver line is fixed that if you learn this much, you can be called educated. That's one part of education. Other part of education is that education has no limits. Real education, you are exposed to real education. You learn whatever you learned in your field, or even you did not go to university, whatever you learned through your technique or through your, you can say, clan transmitted knowledge, you work on that and you say, I acknowledge it and I am now learning practically and I get much more benefit when I learn practically. Because practically it is very much interesting. You see goods are being produced and you feel pleased that yes, my knowledge is beneficial in obtaining these goods by process of engineering. Though you did not learn engineering, but it's the process of engineering. Every activity that you do in your life is process of engineering, whatever it could be. There are very, very small activities like plumbing work, masonry work, carpentry work, welder work, or you can say steel fixing work, technician work like machine operator, or you can say pump operator, concrete pump operator, or you can say equipment operator, or you can consider whatever you wish, electrician, whosoever use whatever kind of technique is called technician engineer. Even though one has no educational background of engineering, yet it is technique, application of technique is part of engineering practically. I have seen many people in world who never have been to university, never have been to you know never have been to any place in world of education, but you see they are they are involved in practical application, and that is what we call it, that we call them that they know what they should know. They are well in practical application, and they people sometimes are successful to unexpected extents. That's very important point we have to take into consideration, that life is not exactly hell bent based on education. Engineering education is never original. It comes from execution in field, and it moves on to educational institutions in form of practical knowledge. Practical knowledge is very much important. Is very much important, is very much important. If don't have practical knowledge, I think we cannot do anything. That knowledge is very much important part of our life. Practical knowledge gives you something you can never get otherwise. Practical knowledge is very much important everywhere, and if you don't have practical knowledge, I think you cannot do anything. Even if you are educated, you are graduate engineer or master's knowledge you have, or doctor you have certain limitations of knowledge, and when you work in field in whatever capacity, you learn immensely if you are interested and if you got opportunity in such a way. This point why I explain every time, that do not disregard those who work, of course, not having big educational background or considerable background, but they can do what in general educated people cannot do. I have seen many hundreds technicians in my life, and I note when I had a chance, I used to note how they used to work, and every nationality had different style of applications of engineering. That is also true. Every country has different approach. You can say how application is done, how people think it can be done, what is the style of their work culture, everything that you can think of. But output remains same. Mixing, say for example, mixing of mortar, plastering, rendering, brick walling, you can say block walling, how to work on activities. There can be different procedures, different way of thinking, but when you get results, it remains same. Of course, with little variation, speed of working, of efficiency of working, output, and you can say confidence. When I say confidence is real part of life. If you get confidence into something, I think it is best way. Confidence, good confidence, general confidence, high confidence, very high confidence, it is all required in life. No confidence means, I think you can say, it is waste of time. You may be having educational qualification, but you never worked in field. In that case, I say you cannot earn confidence. Earning confidence is only practically possible when you are exposed to practical activities. Even in designs, if you don't design for a long time, you are bound to forget procedures of design. You are bound to forget applications and formulas and theories. And if you remain in touch, you you have full confidence that I have done this many times and I can do it now with more vigor, with more confidence, with more you can say trials. In beginning of designs, you can say, okay, I got this procedure, I got this formula, or I have more formulas with me, I can find what is required. But if you don't practice that many times, you can't do it. Means you will take first of all long time, then you won't have experience and confidence. Experience and confidence are directly proportional, provided genuinely you learn something, genuinely you do something. If one design activity you do one time, first time, you will be having many missing informations, and you will collect informations of those design parameters. Then you will find results after application. You will learn what answer should be or it should come. You cannot compare it until you have many applications of same design or similar designs. You can then know what result it should be and what this design is giving me. And if you don't have experience, don't have practical iteration of the design, you cannot say I am sure of this. Sometimes you can enter wrong data, and this should be immediately discovered if you have experience. And if you don't have experience, you would say I'm not sure what's saying. Then you ask someone else, I'm getting this information, this result, is it okay? Do you think it's right? That means you are not a designer. You are just a learner, and this learning shall take a lot of time because you have no confidence. And that's what I'm saying. Rather, depending on exclusively your software system, you depend on your mind calculation. It gives you much more idea, because confirmation of design is done by detailed designing, but actual design is done prior to detailed designing. As I said in last talks, that we have to understand structure. If you understand structure, you can do a lot. Detailed calculations would follow, no problem. If you learn structure, if you know structure, if you understand structure, it doesn't need every degree or diploma. It needs your confidence, your mind setup, your vision. What do you want to see this structure about? Means how do you want to see this structure? No. It's also not necessary. Whatever you view or preview, you will do same. It will just give an input of how you should proceed. I have experienced many times when I draw plans for some plot, plotted housing or whatever else. Means when you work on drawing system, you start something, and what you keep in mind, sometime it happens, sometime it doesn't happen. Then when you progress on drawing, with free mind, not with some other's instruction, you'll find that a stage comes after your drawing system works, your sketch works, or your prototype in mind, whatever it was. When you follow up on that, you'll find a stage comes on your design itself and drawing itself, that drawing tells you or design tells you you are going in which direction. That stage, up to that stage, you moved with your own conception, and when you reach the stage that the drawing starts telling you you are going in wrong direction or you are going in right direction. That stage, you can say it's called the pragmatic stage of drawing itself, because you produced as drawing, but now drawing has assembled itself to a stage where it can give command to you. That is important. If drawing or sketches gives command to you, now mister, you are wrong, there is something wrong, you just check it. And you'll detect it immediately, because it is drawing and it is accurate. Line may not meet, point may not meet, something could happen. So how double line is coming here, or this, something wrong somewhere. So that way, when you plan something, say in the civil engineering, I plan some plot of how many square meters it is, doesn't matter, but I think even smaller plots cause problem, not bigger one, because there's a margin. But smaller plants, you have to think a lot. Let us say 32 square meter plot, or 40 square meter plot, or 50 square meter plot, or sometimes 30 square meter plot, or 25 square meter, and you find that problem is always there. So there are so many issues that you don't follow. Always you become your own leader. When I learned all this, when I came with problems, I could not even resolve what is the height of riser, what is size of tread. I'm talking of staircase. Means people say, what is height of your floor to floor height? You just divide it by this and you get. Sometimes it happens that I used to confuse myself because there's no direct answer on books or somewhere what you should do. They say you can design a stair like this, but you don't know how to design that. Let us somebody says you, oh, height, floor to floor height of this room is 10 feet or it's 3 meter or 3.15 meter or 3.25 meter, whatever it is. Now you have to provide design for this, and I say, okay, this is height. But why you want to keep this height? The question is that. No, this is general and these are the. So what happens when you divide by certain number of steps, you can say number of risers, you don't get round figure, you don't get whole figure, you get something in decimals. And that is where you have to learn. So I decided myself, there's no reference in any book or somewhere. I thought, means what this nonsense is, why should I think of in decimal places the riser right? Riser height, why should I think in decimal places? Or it sometimes come, oh, this is 5.55 inches. Oh, no, this is wrong, I don't accept this. So I decided, let us move in a different way. Let us fix a height of riser, let us say 15 centimeter or 12.5 centimeter, whatever you think, it's comfortable, because lesser height of riser is better for old people, for kids, and of course when you are moving up, you ascend stair, you work against gravity, and when you work against gravity, you have to apply higher force. So just to reduce that quantity of higher force, you just try to reduce riser of stair. And by chance I'm telling you stair, I don't know why it came to my mind, because I was going through some design of stair on YouTube. So sometimes what happens, I've seen some very you can say stairs, stair flights, so having an angle of 75 degree, and I am surprised, means it's risky, you cannot take so angled flight means 75 degree flight means, and you are providing riser say 8 inches or you can say 20 centimeter. That is not good, when you go up on a stair or you ascend a stair, means you may be an old person, you may not be so energetic, means first of all it's very difficult to move on that, because riser is height, and your weight is downward, acting downward, and you have to move upward. Your weight is acting downward and you have to move upward. This means your force which is downward is moving upward by height of that riser in each step. This means work is done by your own weight multiplied by that riser. That work is done by you in vertical direction. So you have to apply more effort, because that work is to be done in each riser. And how many risers are there? That time you have to work. So of course you will get tired, you will get fatigued, and you are a very senior veteran. It shall be very difficult for you. This is first application of efforts, and secondly that there's a risk you may fall, because you are working against gravity, and also while you descending from a stair, same thing happens in another risk, that means you are applying, though you are not applying that efforts, but there's a risk of fall, because when you come down it's more risky than you walk. So my opinion changed. I said, no, if you have adequacy of space, you should act smartly. Don't act why you squeeze stair when you have plenty of space. Say you are making some building in village and you have enough place, enough space, why to be miser on utilizing that one? So I think now we should do different way. This is not right way to find height of riser. I am fixing height of riser. So I fix, okay, it may be 150 mm, or you can say 15 centimeter. It can be 125 mm or say 12.5 centimeter. Let us fix height of riser, and let us say how many risers do you want in normal story height. Let us say we fix 20 risers. If you say 20 risers of 150, so it is 3 meters. Okay, 3 meters is a little less, so we keep, let us 2 risers more, so we say 3.3. I say, okay, 3.3 meters or 3.15 even, depending on what is permissible for you. So I say, no, we fix height of riser, that's better. Thread can be adjusted 20 centi, 25 centi, generally it is 25 centi, 9 inches or 10 inches. But there's a flexibility, because the thread is not going to cause that much problem, except that you may strike sometime nosing by your toe. That could be there, and it may destabilize your foot movement. So I say, okay, let's fix riser vertical dimension, which could be 150 mm, 125 mm, and better not to keep something more than 150 if space allows. In that case, you can decide story height and how many stories in building, and you can say, okay, this is my height of building. I think sometimes reverse is better than direct application, but that you have to think yourself. You don't depend upon books always, because books are written by those authors who teach students. Not if virtually see practically, you won't find number of books that guide you. These professors who teach students, they have their own world, means their destiny, this professor's destiny is to deal with students and research work of a student. You can say how to guide student for understanding best way. And even if project is done, that is also limited. You do one small project under guidance of professor, that gives you complete input of your knowledge. But when you work in field, you are independent. If you are a freelancer, you are completely independent. If you work somewhere under some engineer, you are also self-independent, but to some extent. So it depends. You work in a job somewhere else in organization, then also you have to decide all this. So sometimes you have to think yourself, and that's what I'm thinking. Thinking is principle, and thinking is your capacity. If you start thinking, though you are bound to think because you are an engineering qualified person, and engineering says that you must think. Without thinking, one cannot say that I become an engineer. Engineer is not a follow of education. Engineering is not a follow of field. You have to force others to follow you. That is engineering. If engineer say, no, I have to see, somebody has to instruct me all time, then you are not engineer. Okay, in beginning you can say somebody has to train you practically for 6 months, 1 month, 1 year, 2 years. That is acceptable. But once you are merged in, you have gone through a initial period of 2 years, 3 years, 4 years, you have no right that you always expect that somebody should instruct you. Yes, your bosses will instruct you, but you have to instruct yourself also. Sometimes instructions come to you, you don't understand instructions, go again and again to them. That is not acceptable. That's not accepted. Yes, if there is a problem, you have to go, because some scope is there which you don't know, you are not aware of. But in process is yours. You decide process, that your senior should not explain to you. There are so many processes for same activity. It's up to you which one is best suited for you. My dear friends, I am telling something which is practically done, which is practically useful. So I just give an example of staircase, and moreover, upstairs, if you do RCC work and not using rolled steel joints, something else, stair is very complicated item. It's not because it's complicated in the sense that it has inclined slab or something. There is some other thing, because you have to fix shutters of stair formwork, and formwork is very complicated in staircases. If you just tell some carpenter, shuttering form worker, you can say form worker. If you tell some form worker technician, this is my drawing, you start working on stair, shutters or form work, that person would see your drawing and start thinking what to do. Because this is not direct vertical member of column, or this is not beam bottom or beam sides or column or vertical shutters or whatever else, or this is not suspended slab where whatever direction slab says you have to put your shutters in. It is stair. Stair profile is at top. You are not giving other profile. Generally in drawing you say this is my profile, these are riser and steps, and this is your stair. Drawing thickness of that I will give you, or I have designed also. It may be 200 mm, or it may be 250 mm, or it may be 155 mm. Whatever the design gives you based on, you can say, span of stair. Longitudinal design, generally longitudinal design is done, not cross design. In RCC, longitudinal, what I mean to say is there is landing to landing span. mid landing to mid landing, generally it is taken. That's called span, stair span. Though this waist slab slab of flight, which is called waist slab, this is inclined one at angle of 30 degrees and not generally 45 degrees, but you have to consider its direct load in horizontal projection. Well, that is design matter, design issue. But now question is, you have got design, and you have to make sure that this formwork carpenter should get complete information, or whoever is foreman there also gets complete information, millimeter by millimeter. If you want real stair, if you want accurate stair, you cannot assume something. You have to give accurate sketch based on accurate information, and it is possible, it's not that time now that you can approximate it to some millimeter or some inches. That is not permissible. Stair is very important item in building, just like lift is very important item, elevator is very important item. If stair is not given due value, you cannot build a stair. I am just promising you. I have seen there are errors in stair, errors particularly in risers. You have even a odd number of risers, but you will find that top risers, there will find differences in riser height, and that is not permissible. It can lead to accident. This is against safety requirement of users, because your leg, when you rise on a stair, one step or two step you raise yourself, you don't look at risers, you just keep on moving up. So your mind always immediately programs in taking information from your leg, what riser height you are rising. And suppose you are rising 12, you are moving on 12 or 13 risers, your information mind has already taken, and say last two steps are in different riser, it can give you a kick. That is important point. Even 1 or 2 millimeter difference or 3 millimeter difference can cause a problem. So riser is very important, that it should be equal, 100% equal, all risers up to landing, from floor or from landing to landing. That is very much required. And as engineer, what you have to do, that is important point. I cannot say you don't understand that. You understand that. It's not very big engineering, very complicated engineering, but accuracy is more important here than size of a column or size of a beam or something else which is directly given on drawing. This information can also be given on drawing. It's up to you, up to designer, or up to a person who works on working drawings. You can say, I have given him a staircase working drawing. But what information you have to give on that, that is very important part. It's not line work only. Stair line work is very easy. You can do it once you have decided about riser size and tread size. You can make a stair profile immediately. It will not take much time. You know point of start, and you know your design. You're just lined up one you can say riser and tread at orthogonal angle, 90 angle, and then you just copy paste many times, so you reach up to landing. But that is a step. Step is no problem. Problem is waist. And you can say, okay, I can do waist also. I did design and I'm getting 200 mm thickness or 250 mm thickness of waist slab. Whatever you decide, it is not necessarily as 250. It is because you are saying there is approximation in that. By say for example, you are getting moment of resistance and you are getting bending moment, both equal, and you find this depth is, say, the actual depth required is 15.5 centimeter or 14.5 centimeter. You cannot take like that, because that is from top of that waist slab to center of steel, center of bar. Then you have to add half dia of that main bar, and then other bar if there is there across to that, or next layer to that. Then you have to take spacer thickness. All this you have to sum up and say it is coming 18.5 for example, or it is coming 19 for example, or 19.3. Then you can say, oh, I can take 200 mm, or you may, whatever depends on calculation, whatever size of bar you use. Then you can say, okay, I have to go 220 mm, 230 mm, 240 mm, 250 mm, or 200 mm, or 180 mm. This depending on span, depending on bending moment, depending on what is required, and so you finalize. When you finalize that thickness, then you have to draw that. That is important. Architect would draw something which architect is not concerned with reinforcing detail on all that. So for him, just one line is enough. It's okay. This is column line. You draw column. This I want stay here. Fix it for me. Design it for me. So job of architect is over. Architect just give an indication. This is stay here. I go bye bye. You take care of yourself. That one it takes. Now it comes to engineer, who has liability to construct it through some other engineer or self. So you have to draw real waste, actual waste, and from those corners of steps which you have drawn. So you draw a line which you say, okay, I have drawn it parallel to that waste. You given proper thickness, whatever you approved in your design, and then it goes on to where? It goes on to landing top. Landing top or landing bottom, because landing you already designed. You have already designed landing. Let us say 15 centimeter or 150 mm. You have designed. Generally it is it. You can't say below this. It may be more, but this is a minimum, because slab generally we suspended slab designs of 150 mm. So this is 150 mm, and bottom is also 150 mm. So your waste slab shall strike somewhere on those horizontal lines of soffit of slab and of landing and soffit of slab landing at both levels, at landing level, at floor level, or both landing level. And you say, okay, this is profile of my stair, these are steps profile, this is steps profile, and this is slab soffit profile, waste slab soffit profile, and we call it flight of stair. Flight means landing plus landing, or floor plus landing plus waste slab with steps. This is called flight, F-L-I-G-S-T. Don't think of that airplane. It is something like that. You are landing somewhere. You are landing to floor, or landing, you are reaching landing, and then reaching to floor. So this is a kind of flight, you can say. Well, it's not bad to think it like that. Now what I am saying is, information that you are required to pass to your farm worker, that is important. You have done this is drafting job. But what information should go to that person who is going to fix shutters, and before fixing, that person would cut according to size he gets. That is important point. Because other sizes are mentioned. Size of beams, or they can be even tabulate, you can tabulate and give. But the stair is only item that doesn't give you direct calculation. If you even if like it, you can say, okay, top of landing I have done, bottom of landing I have done, and top of stairs done. But this carpenter requires to cut shutters of apply according to actual size of bottom of slab and bottom landing slab, or bottom of floor slab. That point is very important. So what is required is 2 points at bottom of landing, both landing or floor. I can be landing or can be floor, both, and then connecting those points with waste slab bottom, waste slab soffit. That profile cannot be dimensioned directly. So you have to draw complete drawing of stair portion, stair columns where are coming in between that, whatever structure of stair you think it's within that coverage, you have to draw that one, and then find its dimension. This means there are 3 dimensions which are very important, but you can say not 3 alone, 4 dimensions. One is vertical level or vertical height between bottom of top landing, I mean to say intermediate landing, and floor. What height it is? Actually bottom of floor to bottom of landing, and then bottom of landing to next floor. This is vertical height, but this vertical height is only for vertical purpose. What about dimension of bottom of landing, or soffit of landing and soffit of floor? That must also be depicted on your sketch exactly in millimeters. And this is not whole number, never, not even decimals. So this, and also inclined inclined line of waist, you have to give inclined dimensions, so that when you fix top or bottom of slab at landing and bottom of slab at floor level, there is a point where it is to be cut at bottom soffit and top soffit. Those cut points would be joined by another measurement that your worker, your form worker would cut and fix. That is very important point. And based on those dimensions only, your supporting system would be arranged. So why I explain to you this? Because I have practically seen that just giving some drawing to form worker is not adequate if it is not properly measured or dimensioned, and exact dimension must be given if you want that stair should be accurate. Otherwise, you will find errors in staircase, and that errors are very costing. Will cost you somebody. First of all, it is inconvenient. Your risers are not equal. Nobody would accept that, because risers should be equal. It may be even number or it may be odd number. That is not that much troubling as difference in height of riser. Though it's very small item, people will say you're talking of stair as it is everything. It's not everything, but it's very important, because it is part of vertical movement. Without a stair, you cannot move vertically in buildings or in structures. You cannot move. That's very important point. Railing can be fixed also in same way, because it has to be fixed parallel to waist at certain height. So I am stressing about stair because people just keep busy themselves. Oh, so many point, decimal point, this and that. Don't do all that. Fix whole number of riser and decide ceiling height or floor to floor height. That is best and easy way. Based on my experience, I have stopped taking height of ceiling into consideration or height of floor into consideration. I say, okay, I fix my riser, and I fix riser, it means even if you apply finishes on that, riser would remain same. So you fix riser of structural member. I say this structural step riser is this and its thread is this, and when I fix this thread depends on actually horizontal space available on your drawing. So I think that is best way we have to take into our opinion, and particularly to those who are very young engineers who do not understand site problems. I don't want to give any problem to workers who work on field, because their work is very complicated and they cannot calculate accurately. They will go, or generally they cannot, I've seen they cannot calculate in meters. They go to feet and inches on the other. So there's a mix up of calculation and you cannot rely on those calculations. So best thing is just take 5-10 minutes on your software of drawing and just copy your stair wherever it's, or you make one stair in that way. Make it in a beautiful way. Beautiful means not decorative way. I want to say clear way. It should be easily read. If it's edible, readable, you can say, you will help yourself, because you will not go every time to see what that worker is doing. Inspection of stair is very important. A little error in your waist work, or you can say stair flight work, would cause problems, and you have to be very careful. So this is why I said that site is not that easy as we think. And here what I am talking is not site work. It is a part of operational design or working design. Though all designs are given on drawings, stair design, until you do it like this, if you give on drawing, there is no meaning. That is what I say. You have to work yourself, or designer has to work, or you have to work. You have to give complete information to your operative carpenter. It's not only carpenter. Whatever information is given to masons is also required to be given. All information must be equipped to these people. If they are equipped with complete information, they understand drawings. Try to be clear. Every mason who is real mason or carpenter, or those who work with you, steel fixer, those who are directly involved in technical details running, they know what they can do with these details, and sometimes don't allow them to use their own imaginative details, because that can lead to errors, and only solution to prevent that is that you give them every information you think that you are working on that. See what I again say. Engineer's thinking does not apply only for engineer work, it applies to all works on site. You have to think, if you are working on yourself on that place and you are not having complete information, would you be able to continue? That is main point. Do not run away from information. If you say, I gave you drawing, you did not work, you cannot say that. You said you gave drawing to that person, he did not complete it. By giving your drawing to that person, you think it's okay. And even if you say you explain to that person, these persons are not very smart in understanding sometimes, because they work physically, and if you work physically, you will not be able to work mentally that much. That's also true. So be clear. Whatever information you provide to those people who work directly, either directly you give them information, or you provide that and pass that information through your supervisor or foreman or whoever you think is quite capable of doing that. But do not think that at that time your job is accomplished. You are just given something to them, but you have not explained to them. And even if you explain, they could not understand 100%. They miss 40%, 30%, because your language and their language do not speak same tuning. Do not tune to each other. You have to be different person, because you are educated, and this is your responsibility to provide information to all these people who work for your job, for your project. So here I say information is very important. Why there are some problems? You say there was some information lag, there was some misinformation, people say, or they say it happened because of miscommunication. Yes, that is right. And this is what is miscommunication. Actually, there was no communication. You thought I have done my job, and then you fight and shout on that person who got some error on that job. That person is not of your caliber in theory or in writing. Drawing is given to him. That person understands drawing indeed because of experience, not because of education. Sometimes you give some sketch or some part of drawing. Everybody on site, those who have experience in construction, they understand, because they do not coordinate. You have given one drawing or two drawing, and they can, okay, I got it, I understand. It's not their duty to go into coordination, to go to engineering, tallying with each other. Same way, dimensioning is not their responsibility. I mean to say, responsibility in the sense that you have to do right work. I'm not talking of liability. I am talking of responsibility, that work should be done according to design. Quality is something else. I'm not talking quality here. If these measurements are done on site, then question of quality comes. So stare is very important part, remember. And if you do not realize this, you have to realize this. Stare can make many mistakes. Suppose there is an error of 2 or 3 centimeter in one riser. You have to either make it higher or lower to meet that floor. It is really ugly, first of all, and it's going to cause safety issues. And safety issues are very difficult issues. It is not permissible to produce unequal risers. That is very important point. Well, I explained to you because it's very important. Now, I don't know how I moved into this position, because I always take care of steps myself. If required, I sit there with that form worker on site, as I used to do in my career. If not all time, while passing through that location, I stand with him and see what he has done. If there's an error, I have to explain to him, no, this is right or this is not right. You have to take it, say, do it like this. Sometimes foreman may also not tell, but if nowadays AutoCAD is there, you can draw and give. In those days we have to calculate, and that calculation, because sometimes it was in meters and sometimes it was in millimeters, sometimes in feet, and it's very difficult to express or give exact dimension, and which really creates practical known errors. I mean to say, these errors are not hidden. This would tell you, I am wrong here, my problem is my height is not same, and you have no solution except to keep differential heights, and that is not going. It happened in one case. I remember I was in Arab, and one there was a difference in riser, in 2 or 3 risers, and that lady collapsed because of different heights. They raised claims against that. This is your construction, you produced this, and millions of claims were raised. I fell, my leg broke, or my this happened. It's because of your construction. So, my dear friends, life is not that easy as you think it is. If you make errors, this error can lead to many problems. And nowadays, health, safety, and environments are very important subjects, very important fields. So we have to take care of everything. uh, Stair is one part, lift is another part also, because lift is very important item. It is also dynamic item that aids to your vertical mobility, aids for goods vertical mobility, and which lift you are using, that is also important, and what sort of lift it is, that is too important. It's having, you can say, it's having its room at top, or it needs some pit at bottom, or it how much space is required around its car. All these are very important, and these are such a points that are involved in coordination activity of your work. When we talk of buildings, or particularly those buildings which are structurally framed, I'm not talking brickwork building or stonework building where all walls are assumed to be load bearing, and whole structure is different type of design. When you say I am just designing a brick building, or stone or block work building, I say block work or brick building, these are same for me. You have different approach towards design. When I used to study in very beginning in my polytechnic, our lecturer used to say, yeah, up to 3 stories, don't think too much. You have a 9 inches wall, brick wall, it can take loads up to 3 stories. It's kind of a thumb rule, and I don't accept thumb rules, but teacher said, because you are going to construct buildings, and do not waste time. Up to 9 inches wall, or one brick wall we used to call it, it's good enough up to 3 stories. And when you go for design of foundation, you have to take it down with the spreads, or offsets of half brick here, half brick there, or one brick like this. So twice thickness of wall plus something, to twice thickness plus 1 feet or something like that. It was a thumb rule, and we used to follow up that you have to excavate this much depth with this much width, and of course with some working space, and your foundation is in this offsets. So how many courses you have to provide, you have to see that. And a section was prepared. This is excavation, this is the lean, we used to call in those days lean concrete, though it's not lean concrete in terms, well, terminology is no problem. We call it lean concrete or blinding concrete, and on that you have to do so many courses in 2 layers, and so much this width of bottom course and top course, to say 2 or 3 courses or 4 courses, then reduce this and make 4 courses like this, and that is your foundation. And when you reach plinth level, that is called the floor level, you have to provide this concrete thickness 25 mm or 40 mm, that is called dam proof course. This was general. In general, I joined my diploma in 1971, and I think in those days there was no advancement of RCC, no advancement, nothing, not even, you can say, we used to work on using log table calculations, not even calculators were available. So that was different world, but it was engineering. And they used to teach us about masonry, which type of steel masonry, how many classes are there, how it is done, and how many bonding in brickwork are there. This all, still it is valid, but we don't find that quality of bricks. We don't find that skill in brickwork. I have seen rubbish work is done by people because they don't have good practical training from their people who they have. There's a clansters, you can see, there are forefathers who used to do same. and there's no formal training given in any institution or ITI or somewhere. So it's different. Means engineering moving is moving fast, and now RCC and pre-stress concrete and all this, many classes of concrete have come. We have to be little different. We have to be very smart and try to achieve accuracy, and that's also a part of quality. Though previously used to call it part of workmanship, but all come under umbrella of quality. So stair I explain because it's very much important item, and stair decides sometimes what plan you have to do. People come to me and say, you have done this stair this way, please make some changes on this. I say, sorry, I will not touch stair. I have done it, given to you in design. If you don't want to do it, don't do it, but don't ask me to change it, because many aspects I thought, many angles I put in my mind while designing this. Particularly for small plots, it's very difficult. Very fine, very squeezed space. Yes, if it's a big plot, 200 square meter, 300, 400 square meter, 1000 square meter, there you have option, you have many probabilities, you can take whatever you want. But in a small, particularly if there's a 35 square meter plot, 25 square meter plot, where you have to think a lot. So do not say, do not ask me, do not even expect me to help you once I have decided stair. Yes, something else can be done, but stair can't be changed because it is very squeezed area, and I do not accept what your mason says. I say if it is done, you have to do it, because structure is also to add it to this. So do not take it too lightly. Remember, small is always difficult, big is easy in work, because if you do big plot, you will have many locations to do whatever you want to do. But in a smaller one, stair, and you can say WC, and where put electrical distribution board or some other services board, where to put, you can say, your water pump, how to fix a water tank on roof. These are so many issues, services issues, which make you fool, make you, or make you, you can say, nervous. I'm not getting this space, I'm not getting that space, and owner expects every facility. And of course, you have sometimes I have seen stairs very unbecoming designs of stair. That is first of all very, it is very unhealthy. It's not convenient for user, and it costs also, and it's very first of all, when riser is higher, it's already bad design, you can say. But in smaller buildings, you can say there is no other choice, you have to do that. I thought today to talk something very relevant, and that's why I'm doing. There's a part of design, may not be that much in a structural, but it is design. And also design doesn't mean only stair design. Then you have to think of, you can say, ventilation. You may call it architecture. No, it's not architecture, because when you draw, when you start drawing as a draftsman or as an engineer, when I say stage comes where drawing starts to become your teacher, your own baby, your own work at one stage starts to conduct as if it your teacher, and that is true. You cannot move out of that. Either you change everything, you erase all and do it again. That you won't like to do. You will say, I leave it here, I copy it and amend here. And you will confuse and you will make rubbish, or you may be better. Sometimes it happens. Because it is drawing, it is accurate. It is not that drawing we used to do on drawing board before and past. I think in 70s, in 80s, we used to work on drawing boards with T square, 2T square, T square, and set squares. Yeah, I remember one was T, like this, a little timber T, T shape, ruler like this, big one, put on inclined drawing board, and there were set squares put on on edge of T, and we used to work with pencil and rubber and fixing drawing sheet on that board, and we show, okay, we move like this, fix a sheet, and then we use horizontally this way and vertically this way. One set square is 45 degrees at right at 245 degrees, and one right angle, and other is 30 degrees, 16 40. You know what I'm saying? Set squares, one was right angle triangle with 45, 45 and 90 degree, and other was with 30, 60 and 90 degree. These set squares we used to work with us, and we used to do all work on drawings with these, with pencil of course, drawing sheet, rubber, and of course a scale. So it was a complete different world where you had to do practically on drawing and not just command given to computer software. Now world has changed, but that was more artistic and more demanding, because you had to stand there and work on that. And if you could not get it, you could not produce immediately something, you had to try, you had to do, and once you, even though it was erroneous, you feel, oh, I got errors, difficult, I had to rub it again and do it again. That was interesting life. But remember, mind was very active that time, very active mind. Every drawing board, every draftsman, every engineer, they used to do something themselves. Of course, job of draftsman is to draw, but engineers, if you just kept on instructing, then you would not get that much. I heard then that German engineers and many West or European engineers or others in England, they used to draw themselves, and that is interesting one. I tried to do that myself also, and I benefited. It's not because you become draftsman by time. After all, it is engineering language. Drawing is engineering language, you know it. Drawing is not scripted language, but it is line language. It tells you what your 100 pages cannot tell, one sketch can tell you. So drawing is something which should be very much communicative. And time should be given to it. Time, that's very important. And when you draw something, your mind thinks of how you are going to do it, how you are going to see it, how you are going to use it. Okay, I have produced this line diagram, and this looks very nice, but I forget to concern to take into my consideration columns and beams of this, how it shall be, and there what happens. You just do your line work in whatever way you do on architectural front, but your structure demands something else. Your structure demands something else. That point you understand only when you start to think, how shall I fix my framing on this? It's really very, very interesting if your framing fits in easily, but generally it causes problem. Because while you were drawing rooms and this drawing room, this bedroom, this room, this that room, this toilet and this all that, your kitchen, here is entry, here is this and that, you did not think, how shall I transfer load of this slab or rooms onto my structure? That is where sometimes problem lies in. Structural work and architectural work. I'm not talking of architect, remember, I'm talking of work. Structural and architectural disciplines should move together. Move together because question is that architectural word is a word of attraction, it's a word of decoration, it's a word of convenience, it's a word of psychology, it's a word which tells that it is your home, it is your acoustic requirement, it is your cultural requirement, it's how you live in, which direction you have to sleep and which direction you have to weep, which direction you have to use fire and which direction you have to use water. This is assumption. I am not saying that is scientifically true, but considering being what people expect you have to think that way. Which area your drawing room is best, which area your toilet is best, from many considerations, how sun rotates there or earth rotates here, what time you are getting sun rays, and how wind flows in that area, and what is orientation of your entry of home, what is orientation of your building. All these are architectural or cultural points that must be kept in view, so that your house acts as as an excellent service provider to you. Now I should say service provider, because house is also a service provider. So it cannot speak, but it gives you service. So that service provider should give you service, and that service can be done only when you design layout of that house or setting out of that house. When you design, start something, don't think that you have decided everything. Again I say, stage comes on drawing board when your drawing says, no, it's not like this is wrong, it's like that. That stage is important. And you have to then think of, once you enter into that immersion of development of board or drawing, you can think many options there. And keep in mind, if you don't keep in your mind structural requirement, you cannot draw successfully. You draw whatever you want to draw, you will never complete it successfully until you fix in that drawing your structure. That's very important point, because structure is very complicated to fit in. Yes, you can draw independently structure, that's different, but independent structure will not be. That person who draws architecturally, that person shan't say, no, this is not what I wanted, give me something else. So you keep on giving different structures and never seen, and is never seen. So what I say, if at same time when you are fixing walls of rooms, you think how shall it be used for structure, and because structure has another requirement, that loads, total loads, point of total loads. I am talking of loads, I am not talking of bending moment here, because just to explain, vertical loads and your planar area, where your total loads come, that point on your plan of building, and where plan of building itself gives its center. That planar center and that load center, we call them gravity, center of gravity of plan and center of gravity of loads, as much as possible should be near to each other. That's very important, so that your plan remains stable. Of course, within certain limits, you cannot exactly say both should be at the same point. If both are located at same point, that's very good, because your building is free from torsional movement, or you can say unequal movement, bending movement. If it is in same point, then it's good, because you can keep building, you can say stable. But if there is a difference, let us say whatever difference, minor or major, then that difference will impose certain moments, bending moments, in building at every floor as well as in foundation. And those additional forces then must be absorbed by additional provisions of structures in that structural steel, I would say structural provisions, external time provisions. So that's very important point. When you say you're drawing, you must keep that structural requirement into your input as input, otherwise you are lost somewhere. Even if you are very good architect, you cannot do that yourself, and if you cannot do yourself, your assistant cannot do yourself. Ultimately you send it to structural expert, and structural experts also waste time, because you did not design architecture so in tuning to required structures. And that's where the coordination is very much useful there, and you call it architectural structural coordination, and that is very much important. And if you miss it and you declare everything, you do everything, I think you will not be able to successfully accomplish that job. That's what I say. Sometimes people don't understand and they keep on fighting. Oh, see, now I want column here. You architect says, I want column here. And not only I like this column here, I want to size, I to limit its size. And that stage is a critical stage because first of all, it is your choice where you want to call. I want column, I want elevational column, and this elevational column was also structural column, and you give difficult work to engineer, or you can say you make structural life difficult because that won't provide you can say required equilibrium. It will be out of gravity and it will be, you can say, it will lead to destabilization or unequal settlement of structure that we have to take very heavily into our consideration. If we don't take heavily into our consideration, we can say it is wrong somewhere. That's a very important point. We have to think of this and we have to understand what we are saying, and really it is also surprising that why don't we understand this point. This point is very, very important to understand, and if you don't understand this, it will not allow us to move further. And that's only reason that I included in this talk stair and how to plan. And how to plan is not simple answer. Every size, every length, breadth, and every requirement moves from requirement to requirement, and that requirement is very important because we have to care about that. If we don't care about that, we lose something, and that is really ill warranted. We can say that is ill warranted, and we have to be in our senses to understand that. And I never force someone. I only say, don't worry, first let me take care. And I sometimes people come to me and I ask them, what about soil and what about structure? They don't want to get it, they don't know it. But I know that it's innocence that they don't understand because they don't know about this. So it's not their fault, it's awareness fault, means they are not aware of this. They think it's easy, everything is easy. And as I usually say, what you see in construction world, construction is not that. I tell whoever is there because you have to educate people. Once I was sitting with my friend, highly qualified doctor, and as usually they think whatever is done is done. I explained to them, see, he just saw one thing. I had IS 456 at that time with me kept on my desk, and he asked me, what is this? I said, this is this is code. I said, what's that? I mean, say, see, Dr. Saab, it's not simple. What you see is what on site. It's not simply that. There's a different word. This code is one of many codes. 456 is concrete code, and it gives you what you have to consider when designing some building or some structure. Every force is considered. And the doctor was surprised. Yes, is it like this? The doctor said, I even take it. Suppose I am standing. What's my weight? What's weight of this baggage? What's weight of the trunk? And at what place it is? And how much load shall go? This floor is there. This wall is there. This column is there. What is their load? We calculate that load. We have some ways to calculate that. These codes give that, and we have to do accordingly. We cannot go. And there are not only few codes, there are hundreds of codes that we have to relate to. Only then we can say what should be size of column, what should be size of beam, or what thickness slab should be, or what should be foundation design. So you see, it's like that. Yes, we consider everything, every point which you people do not know. I cannot say do not know, you are not aware of. That is what he was very You do like this? Yes, we do like that. Every designer does it, but people do not know it. That's the only difference. So what I say, 80% of engineering activity that is done behind scenes, people are not aware of. People are not aware of because they do not know when they get building it is completed. One foundation is not seen, reinforcement is not seen, even surface of concrete is not seen because everything is finished. So it's a question, means public is unaware of this. What public sees, public is unaware of engineering, but public is aware of other fields. For example, medical science, public knows what is pain, and public knows it is doctor and nurse that will help. So they go to them, and what doctor says they accept. But if somebody comes to engineer, that person doesn't accept what engineer says. That's another point. That person accepts what architect says, because that person thinks architect is main responsible for this building, while fact is different. Architect is responsible for spaces of building, not for, you can say, strength of building. That's the difference. Space design is responsibility of architect. Space design, space, not that space. I'm not talking of that space. I'm talking of building space. Volume, you can say. Every building has volume. Length into width into height. One story and then many stories, or basement, or whatever it is. What best way that space can be used, that is called design, architectural design. That is part of only use, how to use this space. It does not mean it says how strong this structure is. Only envelope. Envelope, external envelope or internal envelope. Envelope, you know what I mean to as envelope? When I say envelope, length into breadth, volume, a box, say building is a box. You can say ground level and top level of building. It's complete box. How this box is designed, what you see from outside, and how this box is designed when you go inside and see every floor, stair, lift, all. How it looks, that is internal envelope. So there's envelopes in building, and design of spaces covered within envelope is called architectural settings. But how strong they are, how strong is this building, these designs do not tell. If you want to know that, only structure would tell that. And structure is done by a structural engineer or civil engineer. It depends what size of building is. Civil engineer is a structural engineer to some limits, and highly profile educated structural engineers and highly experienced civil engineers who have experienced whole many decades on buildings, they can tell what it is. Concrete is generally used in buildings or in other structures in our country, and concrete technology is not only spelling of concrete. Many times I tell it, I use it. Concrete is immense technology nowadays. As material, as relative material, when I say relative material, related to concrete, then steel, combination, or other chemicals, we have to respect concrete. Concrete is bone of building, is casing of building, its body of building, its soul of building, and it is operative of building. Though it doesn't operate itself, its properties operate. Concrete has to respond to fire, concrete has to respond to wind, concrete has to respond to thermal energy, concrete has to respond to shocks, concrete has to respond to live load, concrete has to respond to actionable loads, concrete has to respond to temporary loads, concrete respond to every load, rotary load, whatever load is coming, whatever we call load nowadays actions, whatever actions appear, concrete is responsible to resist them or digest them. So role of concrete has spread into many wings. It's like a flight of building. Building is a flight, you can say. Flight which cannot fly, which is held by its roots, and that is foundation. Foundation is the root of building, and foundation only can work for building if it is properly done. If it is not properly done, it can also not work for building. It may move from its position, it may tilt, it may sink, and that would impact building as a whole. If foundation sinks unequally, it is very dangerous because building is higher. It may incline more and come down. There are the cases, many cases in world, that in China building collapsed because of overturning. Point is this, that building is done in ground, foundation is done in ground, and it is a structure we call superstructure that is exposed from ground. Superstructure has to be done in accordance with what foundation is. Foundation is responsible for whole building, and if foundation is defective, building is defective. This is design criteria that we have to consider. That's why I'm saying design. I'm not jumped on to contracts yet, but contractor's job is to do what is given until it is EPC. So we cannot blame contractors when criteria of design remains questionable. No one has right to question those people who are in execution world where design is given and they do on that. But if design is erroneous, it will spoil everything. That is very important point. Every building, when well designed, is welcome. Well designed, well thought design is welcome. Cost is one part, design is another part, accuracy of design is one more part, and implementation of work is another part. So you can say design, then design review, then design agreement, I mean to say design final, and then after contracting system is over, I mean to say work is done on site, then you have to come into disciplines of all, like planning, like safety, environment, and you can say like procurement, or like working designs and drawings. All jointly do work, and based on that joint coordination work, site moves and we do work on site. So that site work which is performed, which is done, is based on what? Based on all information that you did in design, and that information is worked up, that information is put into practical shape, and we after testing or whatever quality system is operated there, we get building done, and after building is done, its maintenance period is over, building is given to its owner. This point is very important that we have to consider all these. Maybe when you are new, you are not sure about this, but I don't think it is that complicated requirement these engineers would not understand. Now this relation exists that okay, this is design and this is what you have done. People understand that they need some backup from some professional for this building. That's agreed. Yes, you have agreement, you need backup. It's good that you get backup by some engineer, and that is excellent one. That engineer would help you convert this design into physical shape. Engineering is what I explained to you so far is also part of engineering, and what you would see, this part you won't see as user or as common citizen, common person, you may not see, and even if you see, you will not understand anything. This happens. You may not understand anything, or I can say that it's really very complicated for you to understand that. But that's not my point here. My point is different. There are certain fields in engineering that sometimes by virtue of experience you see work, and even you can see how it is done, what are tests on that, and how can it be improved. Though you are not engineering qualified academically, but field qualified you are, and you can take responsibility of that by virtue of your intelligence, by virtue of your application of concentration and your sound mind. So some people who work on site, I have seen that for purpose of site they are good one despite they are not qualified, but they can read drawings. You can say it is because of practice, or because you can say maturity of work, maturity in their life. They think that way, how work is done, and they know something about that. And if you teach them something more, they have good capacity to remember and to use it. Those people are sometimes good, but they need some training from engineers or from those who are good in explaining, and these people can become good assistant to you. Well, that is one part only, but when we say we work on site based on engineering input, that engineering input which is design based, theory based, this has to be kept to work based or physical shape, which is called, you can say, field practical, or whatever you can say. It is called construction engineering. Construction engineering of buildings and other structures is not as easy as people think. Oh, you are in field, you are in site, what you have to do? You are just to do work. People say sometimes like that, people who do not know value of physical work. We should not forget that if physical work is successful, your design is also successful. That point you have to understand. We cannot condemn that work, of course, that is done by low profile educated people, means not professors, not masters, particularly those who have normal engineering education, like engineering 3 years diploma, or ordinary BE or BSc engineering. You can say degree engineer, first degree engineer. Degree engineer, when you are qualified, you are degree engineer, but when you experience of many years, you are not degree engineer. You have upgrade yourself. That upgradation also doesn't mean that you should have title or some more degree. Means you attain your knowledge. You attain some level of competence. Some level of competence, and competence means capability to work. That is called competence. Competence, if you get, you are suited for that field. And it's same thing, you know more and more with full responsibility, and you know how to do to that level at least. Maybe you're not full wing engineer, but to some extent you can carry out activities so that all specifications and requirements are met. That level of, you can say, technicians type people we can get on site. Technicians type people like foremen, like general foremen, like low profile engineer, or like those who can use material based on technology requirement. This point is very interesting if you do it and you understand it. Now, what I am saying is all so far, you can say, imaginative. You may say that. I think you will think, you think that this man is some disease. He gets up morning time at 3 or 4 and starts talking. I can't sleep, means, well, you may say that, and people say that you don't like to sleep, or you're free, you're no liability, and you have to talk something every day. You have every right to say that, but you have to think, I am not talking for my family, I am not talking for my personal life, I'm talking for those who want to learn something. And that is my basics as engineer, that I have to teach others, particularly those who are not engineers. I have to teach to my junior engineers, I mean to say those who can know something out of me based on some problem solved, and also I want to disseminate this information to people all over the world. It's not only limited to my country. This point is really very, very impressive and surprising, that we have to think that way. If we can think that way, it is beautiful, you can say. It is praiseworthy, you can say. It is praiseworthy. And you should admire it. It is praiseworthy. I just little moved because of my, every day I don't know, tell my problem. Problem is, I know I have problem, physical problem, and I want to, stretching body is very important, timely. And that's what I say. So my dear friends, when I say that you may agree, you may not agree, that's another point, but agreeing is another point, but life is different. Experience and sharing experience with others are two different worlds. I have to die one day, everybody has to die. So whatever you know, you either take with you forever and it won't work. And if you give it to others who may use that in their future, it will not cost you anything. There was a time when people used to write books, literatures, papers, so that others could read. And I felt it was not successful. Institutions publish journals. Journals are written by very highly qualified professors. But that volume, that knowledge doesn't reach to those people who actually work on knowledge application. If knowledge stays in hands of only those people who can understand that, and not to those people who apply that, then there's no purpose of that paper. It may be high research paper, or it's circulated to thousands of engineers. Well, I think hardly 0.5% to 1% people take interest. So that is more for sake of record, because the promotion requires so many papers you must have done, or higher membership requires so many papers you must have done, you must have published. If it's that for that purpose to achieve that goal, I don't think this is beneficial to people. My knowledge should reach, it is best if it reaches to those artisans, those technicians who work in field, and if they can grasp something from my experience, I think that's the best one. It should happen that way, because if my experience is limited to me only, and I think it's okay, I know it, but even if it's my site, I know it, I don't tell them what to do, what not to do, then I think purpose of my knowledge is defeated. This means only I can apply my knowledge, not they. When I say my knowledge, it's not my knowledge alone, I am taking for all the experienced people. When I say my, means engineer's knowledge. You should not take it otherwise. So that knowledge which you think you have accumulated, you have pulled in for public, it should be disseminated to people. And only way is either through paper, or through writing, or through direct speech, or through video. Writing takes time, but you write something, and if it's not published, then purpose of writing is also lost. Because without publication, people cannot read it, people are not with you. So point is that now we find some media. We can use this media for that purpose, but people should have interest in this media. They should look for knowledge. And if you want to use that knowledge, you have to understand that knowledge. You have to create more knowledge out of that knowledge. That's sole purpose. Quality improvement is not easy. Work can be done wrong, and people accept that. So you accept something which should not be accepted. This means you are not doing justice to your profession, you are not doing justice to people, and you are not doing any justice to your God. So only for that purpose, well, I think people may view, may not view. I try to write a lot. I put on many portals, but I find that people do not read that. I did not say that it was my failure, because it's not my job to read, it's someone else to read. Yes, I am not advertising agency. I don't have infrastructure to publish something. And if you go to publisher, they would say this is not university coverage. Your writing is something which people don't look for. We want certain writing that is saleable. Writing that is saleable. So, how to know it is saleable or not saleable? It depends on interest. Now, for students of university, that is requirement. If there are books, they will read because these cover their syllabus, and if your book is good, they can easily pass that examination. So that is academical requirement. But when quality improvement is required, that requirement doesn't do, because quality improvement is done on work, and students do not work. Students only study. Their teachers do not work, they only teach. Then who works? Then practical engineers who are in field or in industry, they work. So your knowledge should reach them, but they are least bothered about writings, they are least bothered about lectures, they are least bothered about something, they are bothered about job. On job, once you get job, you are least interested in something. Okay, I have got, because that age is like that. Okay, I am okay, I have to settle myself. No problem, I would settle myself. That happens. Nobody can, you can say, change it. Even if you are good, you may refer to books for updating your knowledge. But that, I did not find books which can help site work. Really. I visited many places. If I can get some practical information, I got from nowhere. I worked in Iraq, I worked in Libya, I worked in UAE, I worked in Qatar, I worked in, you can say, Saudi. I did not find, even in my country, I did not find any such literature that gives you reinforcement of update. Don't think it's still reinforcement, I'm talking something else. I did not find that. When I joined my profession in field, a profession means service, job, I did not know how to do work. Yes, text work we could do, calculation work we could do, quantification we could do, designs we could do. But what I am talking, not that. Quantification, designs, you have to do, there is no other way. And if you don't do, who would do? That's another point. If you don't do that, who will do in your place? You have to do that, or you must have some support for you, so that they can do for you. Right? You must have a support that they can do for you. But that is your part. Academical part also, it is designs, quantification, because your site workers cannot do that. It is only you or your support can do it. Support means your immediate support. You can be diploma, they can be other experienced people who can perform such activities. And nowadays it's very easy. If you understand drawings, if you can take off quantities, you can work on worksheet, and you can find at least calculation is easy, not take off. Take off you have to do, take off you can do, and once you formalize it, I think you can perform faster. But site work is still site work. It's still site work. It has not changed and it shall not change because it is physical work. Automatism doesn't work everywhere. Physical work is done, and where quality is very important. Now, how work is done, that is another part. I don't want to waste time on just one point. I have shared with you FIDIC documents before. What FIDIC is? It means contract format. Contract format, you can say, or contract design structure. How contracts should be, how they should be designed. Because without contracts, you cannot move a single millimeter. You can say, why should I need a contractor? That should be first point. You are an engineer. You do yourself. Very good impression. Do yourself. You have learned it. Right? Engineer I am. I can do myself. There is no harm. I am qualified for that. It is my professional duty to do it. But quantity is important. How much, what size of that project is, how much material is required in that, that makes, that commands, that mandates whether you need a contractor or you don't need a contractor. So contract is somewhere, sometimes, all times is essential because of responsibilities. Techniques are so complicated, technology requirement is so complicated that your activities do demand availability of contractors. Because contractor cannot be treated something third class, which I think our people consider, unfortunately. Contract is something, you can say, a kind of organization, a kind of institution, you can say, if not something else, a kind of method, you can say, a kind of blueprint, you can say, which without which implementation of projects doesn't work. It doesn't work. It's a kind of specialty, you can say, specialty in engineering world. Because contract, and of course certainly construction contract. Why we need a contractor? Why do we need a contract? These questions must be answered. It's not my requirement or my you can say pleasure that I need a contract. No. Every day we use money to buy something. We buy so many things or services, and we cannot have written contracts all time. If you have maybe some AMC, for example, in your home, or some warranty guarantee card and AMC, etc. These AMCs are contracts. They give you some document, this is your AMC, you pay this much money and we will do this service and this service and this service. That's what they say. That's right. So somewhere contract exists. So what I say, your contract do not define document, not you can say agreed document, but even if it's verbatim, you are paying for that service, and that contract service provider gives you that input already done. That product is delivered to you by or through this contract application, contract performance. When I say contract performance, this means contract work is done according to provisions included within your contract. Contract documents, contract forms, contract drawings, contract details, or whatever you can say. Really, it is interesting then. We should be happy. Contract. My justification is there are two parties. One party has money. That party requires some work done through someone, and that person who does that work for that work, employer accepts that person and accepts for payment. So contractor shall get payment, or that party shall get payment, and employer would pay. So employer is part 1, and that person who is getting payment for work done, that is part 2 or party 2. This is very, very logical. Not only logical, very clear. This is very clear that contract means a bipartite agreement. Bipartite agreement where two parties are involved. I told you, employer and contractor. Here, everybody cannot be contractor, because this is professional contract, this is engineering contract, or you can say construction contract. A person or a company who got long experience, expertise, only can become contractor. Because our job is not easy. This job is technical job, complete technical job, research job, design based job, and procedure based job, liability based job. It can cause accidents, it can cause losses. There are so many inputs, so many requirements in contract that must be fulfilled. So everybody cannot be selected to become contractor. Only that person or company who is well experienced in that can be shortlisted for purpose of bidding. So contract is a long duration time for certain goal, certain objective to be done according to certain requirements of designs and otherwise, that for a consideration or for a sum of this much, that is contract. You are going to pay something for someone to do it for you, that is contract. It is so simple in definition, but it is very complicated in application. Engineering contract it is, engineering construction it is. It's not only construction. For example, I say you give me so many drawings, you compose these drawings and give it to me, I would pay you that much. People do like this, hire someone for this. I'll pay him this much, you do so, make so many drawings for me, and that's it. That is also construction contract, but that contract is construction of drawings. That contract is drawing contract. Like that, there are so many contracts done every day. And there is no, you can say, blueprint for them, and you do not demand any signature or something. You pay money and do that service and go away. But what we are talking here is professional contract. Work is professional, project is professional, people involved are professional, technology is based, and you can say requirements are based, everything is based. It's not one day job, it's long-term job. So it is different, it is completely different. So that contract is not ordinary contract, though legally it is having same value as your other activities, but it is everything is defined, every activity, every work, all scope of work is described in this contract. And not only scope of work, complete documents are included from design stage to all, covering everything that is requirement, and it is to some extent that much that you take this document, you study them, and when you win this contract, you start doing that, when you are instructed so to do. That is what beauty of contract is. Now we have certain format that is called contract format or contract points that must be applied to these contracts, which format I have shared with you long back on screen share. I'm talking, so screen share is not possible for the document, but document is with me, and I just tell you what it is. There's an organization that is called FIDIC organization, and it has its offices somewhere, you know well. Its name is FIDIC, and it is International Federation of Consulting Engineers, or another Federation International des Engineers Councils, or International Vereinigung Baden-Württemberg is different language, and forget that. So this FIDIC, it's not it's not mandatory that you do follow it, but it is expert in. It says, for example, this is a red book. It says general conditions, guidance for preparation of particular conditions and annexes, forms of securities, forms of letter of tender, letter of acceptance, contract agreement, and dispute adjudication avoidance agreement. Once again, I read for you. It is general conditions, guidance for preparation and particular conditions and annexes, forms of securities, forms of letter of tender, letter of acceptance, contract agreement and dispute adjudication avoidance agreement. This is some title written here, and this is 99 edition, and this is reprinted or redone second edition in 2017, and this is called general conditions. Then there are many other documents we have just explained to you. Now this is construction document, construction contract document, FIDIC conditions of contract for construction and for building and engineering works designed by employer. This is title of this. I have already covered this to you, but I'm just trying to refresh all that. And here it is that a copyright statement. I'm not going to read that. I am just interested to give you about what is actually included in this document, and that's more important rather than something else. There are so many pages which are giving all background, and that's not important for this. Now it says that typical sequence of principal events during contracts for construction. There are certain, you can say, sketches in this and circuits in this, but what it says a time for completion. Time for completion is to be stated in contract data as number of days, to which is added whatever extensions of time under subclause. Now clause is given, so I will not go into that, but what's important is contents of this document. That's more important. I'll share this you later on also. I already shared with you, or if you can see that, you can see that, no problem. URL are there, and maybe you got everything there. But now important point is what actually this FIDIC says. Now FIDIC has here, you can say, given you a format, or you can say kind of book that you can say can be used for this purpose. FIDIC has given you something here that can be used for some purpose. It has given you certain chapters, what conditions or what chapters with what title are to be considered in your contract. It's not mandatory. Again, I'm saying there is no legal compulsion that you have to take this, but it's a guide that it covers many problems which have been noted in decades since it started working in 1999. You can say 2000. It's now about 20 years that this guideline has been successful in many countries. And this is construction contract, you can say, base, which you have to understand whether or not does it relate to your site, your project, and if you think that it is helpful, then you can go for this, or you can say it's not useful, then you can come out of this and stay somewhere else. This is what it means. So its chapters are very easy, very easy understandable, and there's no very complications in them. If you have some knowledge of contract, knowledge of engineering, and how contracts are done, how people are handled, how materials are handled, how contract itself is handled. That is very important point. Because handling of contract is you can say, if you say very easy, yes, it is very easy, and if you say it's not very easy, I would say yes, it's not very easy. Both are there. If you are a very smart person, you are a pragmatic engineer, you know how to handle this, and it's very easy. And if you say no, I don't know anything about this, then you have to learn everything. In that case, you can say it's very difficult. So both are there. Now, what are actually those points I have to know? Just to explain to you, I am trying to give you that. This is construction contract points. I'm going to see in this chapter 1 says general provisions. That is chapter 1. General provisions. And what does it content? General provisions say it is definition first of all, then definition of, definitions of various titles. Then it is interpretation, what interpretation of these clauses and notices and other communications, laws and language, priority of documents, contract agreement, assignment, care and supply of documents, delayed drawings or instructions, employers' use of contractors' documents, contractors' use of employers' documents, confidentiality, compliance with laws, joint and several liability. Limitations of liability, contract termination. This is in chapter 1. In chapter 2, that is for employer, what it says, right of access to site, assistance, employer's personal and other contractors, employer's financial arrangements, site data and items of reference, employer supplied materials and employer's equipment. This is chapter 2, employer. So chapter 1 was general conditions, general provisions, I'm going to say. This whole is general conditions, general provisions of general conditions, and chapter 2 is employer that I explained to you. Chapter 3 is engineer. This is very significant title because there is always a confusion. Engineer, what does it engineer mean? That's the point. What does engineer mean? While it gives you contents as such, engineer's duties and authority, engineer's representative, delegation by employer, delegation by engineer, engineer's instructions, replacement of engineer, agreement or determination meetings. This is chapter of engineer, and then chapter of contractor and chapter of subcontractor. I'll go to just let me talk a little brief on this engineer. As I said, always everybody is engineer. I qualified, I am engineer, and I can say that I qualified, I have certificate, I am engineer, or I worked in project, I am engineer. Means everybody is engineer. That is true. Everybody is engineer. Everybody is engineer and should remain engineer. But what actually engineer we are talking about? That's a very important point. When we say engineer and that title is in contract, it's not what we think about engineer. It is something, a liability engineer. I'm talking of liability engineer who has liability on project, who is prosecutable, who is directly responsible, and who cannot run away from responsibility. It is that level engineer. Means employer considers this engineer to be totally responsible in definition of contract and to extend this relation to this contract by engineer, means to what defined responsibility that engineer is responsible. There are many responsibilities in every contract, that this is your job. What employer says, I expect this service from you. So to definition of that service, that engineer owns responsibility on that project. And because this can be personal contract of engineer with employer, or this may be salaried one, it is same thing. If it's salaried one, then total responsibility is not shared by engineer, but it is shared by employer. Now, question is, after all, how can everybody understand what is engineer? This question was asked me, was asked this question was asked by some, some engineers who were interviewing me during my procedure of election to position of international professional engineer. Though I have appeared in many such conferences, video conferences in past, in many interviews for position of professional engineers. So this question was asked me, what is engineer? Well, I did not get any shock, I did not get any degree of nervousness, because I have worked overseas and I know what does engineer mean. In our country, people are not clear. People used to think government servants are engineers, they are in governments or something like that, this and that. And if you ask them, they say, okay, you are which engineer you are executive engineer, you are junior engineer, I say, means we reach only to that level. We don't consider something else also, that there is another role for engineer in society and under law, and that role is engineer in contract. When we say engineer in contract, it is something extraordinary. It's not engineer which you talk of. And there's where difference lies, so I explained them with small definition, the responsibilities, everything, what engineer is. To be very clear, to be very frank, and don't run into very voluminous description, we can say that engineer whose title is given to that person who would take care of your project in all respects, in not only structures, architectural, services, electromechanical, all. If that person can do that, I can say that is contract engineer. Define in contract what role it is. In contract, when engineer is defined, and generally in contracts all over our country, contracts are defined and engineers are mentioned there. It is engineer position that is defined, and of course when there is a project, it is person also defined. So that engineer who has been defined in this, you can say, in this situation, that person is responsible in totality for that project, and that is where beauty of construction lies. I'm paining again. I just relaxed. I took out my foot from shoes. So that person who takes responsibility of project, of design and supervision, or only for supervision, both are there. If this is construction contract like which I'm talking, then engineer who designed this having different positions, but this engineer who is going to supervise and administer that contract, that is also called engineer, who is responsible to make sure the designs are implemented according to requirements, and these requirements are mentioned in contract, and contractor has to report to that one person who is engineer, and without approval of engineer nothing can move. I mean to say, if something is to be done, progress to be achieved, approval is to be made, material approval, or you can say all approvals, then engineer has to play a very high profile role. And that engineer can employ any number of engineers, and contractor can employ a number of engineers for their subordinate works or for their assistance. Here it's engineer in contract means he is responsible legally if it is this design, if it's engineer's design, he covers responsibility of design also. Otherwise responsibility of supervision is covered, and it's only employer has to establish who was responsible for designs, because steps go on moving. So we can say in simple terms, in simple terms, what is engineer? We can say engineer is an authority, empowered authority that employer has elected, employer has deployed based on design by engineer, based on budget control by engineer, that in this budget, this project with this technology shall be delivered on designs with approval of employer, and execution shall be done by some contractor to be agreed upon by employer. This design shall be taken into consideration, and this construction of designs shall be done by contractor under direct control of engineer. I'm just trying to explain. Whatever contract says, whatever contract document says, whatever written document says, by which contractor is bound and employer is bound and engineer is bound for supervision, and that's engineer, you can say. Because every engineer cannot be postgraduate, that's not possible. That is not possible, and those engineers who give to employer back complete project delivered according to requirements in contract or in contract documents and within budget, this person takes care of everything of that project from very beginning of design, and then taking responsibilities of all works done on site, and then whatever requirement of contract is to fulfill all that, this engineer, he declares project closed or completed, and employer has to accept that. All these range roles that engineer has to play, that you can say is called engineering contract. It's sometimes very important to understand what definitions are. We cannot keep our eyes closed, we cannot keep our minds closed, we have to understand all this. Once you understand engineer, as I explained, that this engineer is different. It's like, you cannot say it's like chivalry or ours. Now what this chapter says, that I have to read for you, because this chapter is giving responsibilities of engineer, and that responsibility is important one. I'm yawning, no? You may be feeling all our problem now. So engineer duties and authority, engineer's representative, delegation by engineer, engineer's instruction, replacement of engineer, agreement or determination meeting, and then contractor. What is contractor? This is also another explanation. Engineer I explained, now I have to explain also this important entity, important partner. Though you may consider contract in different profile in our country. Oh, he is a stealer, he is a robber, he is dirty, he is corrupt, like that. Yes, everybody is dirty in whole world. Everybody is greedy, everybody is average. So is contractor. What's wrong with that? Only contractor is bad, you cannot say. All are bad, in fact. Those who enter power, they are not true people and they enjoy power. And if they got power, they abuse also that power. So this is common for everyone. Now, we talked little about engineer, and we have to talk little about contractor also, because of course contractor is contractor, you can say, as I said, contractor is contractor. Yeah, that's right. It's 5 o'clock, 6 o'clock, I think. Maybe it is around 6. Yes, around 6. Okay, no, around 6. No, this is my problem, my dear. This is my problem actually. My problem, I can't sit more than 25-30 minutes and I have to again stretch myself. And that is, I should not say again and again. Contractors. A person who is going to do your job practically, in simple terms. Engineer was to supervise job and design job. Engineer had to do the design work and ensure that contractor does it according to contract. That is engineer. And in turn, engineer certifies your payments and your deliveries. But contractor is a person who has to do that job for you, which is in contract. No other would do until that contractor is there, and it is responsibility of that contractor to do job and deliver it according to requirements of contract, in conformance to that requirements, keeping every discipline, sub-discipline in mind, qualitative work, safe work, durable work, and tested work. That contractor has to do. That contractor has to complete that project according to scope of project, scope of contract, and that project is to be used by employer, and that project duration has to be valued. Project duration means date of start of project and date of handover or completion of project. It is called project duration. And if it is there is no problem, no extension, that duration is final, and within that duration that project must be delivered for use. Of course, maintenance goes on. So that is what contractor is supposed to do. This is a contract like that. You are paying me something and I'm doing you this service, and this is what is contract. I will take this much time to do this. This is what is contract. I will charge you this much, or I will give you back this much if I get this benefit, or I will demand more if there's a lapse on your part as employer. This is what is contract. Ultimately, my job is that I have to do this for you, and your liability is that you have to pay me for that. And this is contract. I don't think there's something else. Yes, there are definitions of everything. There are voluminous documents of everything. You have design, drawings. It depends. Means what sort of is EPC, then it's more complex. So you cannot say that. But in essence, you can say he is my support. Contractor is employer support, and employer has to use this support for project benefit. And because only that part, that contractor is expert on this, you cannot say that everybody can do that work. Everybody cannot do that work. Only contractor can do who is experienced on that. And that's only purpose that you shortlisted and used pre-qualification of that contractor, and that contractor works for you. So just I sit down again to see if I can sit properly. This is my problem. I can't stand also for long hours. So my friends, I just try to explain in very simple language what contract is, and what contractor is, what engineer is, and what engineering is, and what employer is, and what is this. If you understand these points, you should respect everybody, because these are all independent parties. Independent means neither is servant to each other. This is only service that is required to be given by these people. Service only. And if you don't respect this, I think then it's a question mark. It's a question mark if you don't respect this. They are not your slaves and they are not your servants. Agreement is agreement, contract is contract. It is both way game. If contractor performs according to contract, then contractor also has certain rights, and if employer pays contractor, employer also has certain rights. Same way engineer is, though engineer is not a party on contract, construction contract, engineer has another relation with employer. But this is supervision relation, this is implementation relation, that contractor works for you and you pay to that contractor. That is what is important. And if you think it's not going to do for you, that is not a way. We have to understand each other professionally, and if we cannot understand each other professionally, project cannot move. There is no way project can move, and you waste time. Project movement is very important. If you can't understand that, you waste your time, you waste your energy, and that's not required. It's question of millions and millions and trillions contracts are done. Engineer has lot of work in designs and supervision, whereas contractor has lot of works in procurement, in working, in arranging resources, human resources, material resources, technologies, engineers, and all others who are required to fulfill that contract requirement. Engineer has every right to decide if there is any dispute. If some dispute happens, engineer has every right to decide. Everybody has its role. We know it well. But this role is not ordinary role. This role, involves liabilities. If employer doesn't do its job, if employer doesn't fulfill requirements, then employer is liable. And if contractor doesn't do its requirement, doesn't fulfill requirements, contractor is liable. And if engineer does not do that, engineer is also liable, not in this contract but on some other contract. That is service contract or management contract, we can say. These points are very, very clear in terminology, in explanations, and you can say in their construction of documents. So we cannot go different way. And now I'll go back to again that template of chapters, which says that what is said and what is done. It now says that we are talking of contractor. Now we go to contents of contractor, and what it says that contractors' general obligations and performance security, contractors' representative, contractors' documents, you can say contractor documents, and I can say training, cooperation, setting out, and also you may say health and safety obligations, quality management and compliance verification system, use of site data. I don't know why it's not getting this. Use of site data, sufficiency of accepted contract amount, unforeseeable physical conditions, right of way and facilities, and you can say avoidance of interference, access routes, transport of goods, contractors' equipment, protection of environment, temporary utilities, progress reports, security of site, contractors' operations on site, archaeological and geological findings. Now, subcontracting, this is subcontractors and nominated subcontractors. Then next is staff and labor. After that is plant materials and workmanship. Then commencement, delays and suspension. After that is tests on completion. Then employers taking over, and then defects after taking over. And then is measurement and valuation. Then variations and adjustments, contract price and payment, and then termination by employer, suspension and termination by contractor, care of works and indemnities, exceptional events, insurance, employers and contractors' claims, disputes and arbitration. This is what is given in these chapters. There are descriptions. I am not going to explain to you all the descriptions today. I just try to explain to you what these titles of designation mean. This is important. What are titles of these designations? These three parties, and then generally trend is to employ another party, though that's not on this contract, on different contract, but for purpose of this contract, to ensure that this contract has been effected well and implemented well requirements. This is what it is, and that is another party because of requirements, international and global requirements. There should be someone who should be neutral to all these three: neutral to employer, neutral to contractor, and neutral to engineer, who got no interest in relation to these people, and that party is called third party, means who is neither a party on construction contract nor a party on services or management contract. That party is called third party. Third party team, or you can say third party or independent party audit, they generally audit all these acts done by these important figures, important parties. Sorry. When we talk of that party which is third party itself says that this is additional one, and this has no direct responsibility or liabilities in joint severity with either of these. No joint responsibility with engineer, or no joint responsibility with contractor, or no joint responsibility with employer. Though that party, third party, is also employed by employer, that is because employer is financer, engineer is also paid by employer, contractor is paid by employer, and third party is also paid by employer. So payment has no direct criteria about sufficiency of requirements. Everybody has direct role to play on that project. Employer role is to pay in time or to manage everything that's supposed to be done. But what scope contractor has in contract, what scope engineer has in contract, and what scope third party has in contract, these scopes dominate what employer has to do for them, and what remaining scope that employer has to do for itself. Those are analytical parts, means scope is very important. When we say scope of work is very important item, which generally only those who deal with this, because when we define scope, we cannot define everything. If we define everything, this will be many contracts then. So scope is in general understood as it is very, very minute, very, very limited, but indicative. It tells everything. Scope tells everything. It should tell everything. You cannot say that this is this or this is that. Scope is not explanatory in a sense, it should be, but it tells that your price includes this item. It tells contractor that their friend, what we are going to pay you, that includes this item. And to tell engineer also, your job is this: design job or no design job, supervision job or no supervision job, or what else services you have to provide. This is your job. And scope also tells third party, your audit role is limited to this sphere. You have to audit this one minimum, and if you can do more than that, that's welcome. So these scopes are very important. Sometimes what happens, I have seen project documents worth in thousands, many volumes of contract, many volumes of specification, and list of drawings in those documents, which you can say many thousands, sometimes many hundreds, and those cover scope of contract. And out of this also It is given this is for this contractor to do, this is for that contractor to do, or for specialist to. I mean, this also variation of scope. So scope of works is very, very important item which starts from beginning of contract composition itself. When you start early pages, scope has to come. And based on that scope, only our ruling partner can do for us. That is another point. So in this talk, why I am stressing all this, that contract is not a fixed one, contract is not hard table. It's up to you which job you want to be done by contractor, what is contractor's scope, and what is contractor's appointed other contractor's scope. This whole issue cannot be understood in 1 day talk or 1 minute talk. Essence can be understood. Essence, I say essence. When we talk of essence, we talk of responsibilities. We talk of what we have to do. And one thing I tell you, never go word by word in contracts. If you go word by word, then you make everything difficult. When you say you make everything difficult, means you do not know what is your scope. Scope is important, as well as interpretation of a scope is important. Liability is important, as well as extent of liability is important. Both are very important. Now, when we issue documents for tender, there are so many written explanations within those documents itself, which those who are experienced in that field, they know, yes, this means is that, they understand. And it should be like that, because everything cannot be understood word by word every time. If I am experienced contracting personnel, I know what contract is, how this nation deals with this, what is lump sum type contract, was item type contract, or what is 24 hours contract, or like this. I understand well. You understand well if you are a contractor or you are an engineer. You know this work involves this much and this work involves this much. So you either exempt it from contract or include in contract. First of all, we have to understand basics of all this, contract basics. Once you understand this, means what contract has to do, and contract understands what this engineer expects to do. And this paper, 2 rupees paper or 10 rupees paper, I don't know what this say, what your books say, volumes say. Books means contract books. Contract books means not contract education book, I mean to say contract document. There are so many contract documents on each project, and these contract documents are very extensive documents, extensive written documents, which your contractor must know what is written, and your contractor should presume that whatever is written in that document, because now that person has seen, seal, so you must be very smart on that, very useful on that. Scope of work is very small sometimes and very wide sometimes. Generally on major contracts, scope is very wide. Scope is very wide in the sense we write a paragraph for what is about scope of work. We simply write that Oh, 618. Scope should be defined by engineer, and it should be clearly defined. Non-clarity is not permitted. Non-clarity is not acceptable. because it's question of material, resources, machines, etc. This we have to understand. A scope is defined element wise or component wise. There can be many components in a project. You can say there may be 5 buildings, there may be 6 buildings, there may be different types of buildings, there may be many parking buildings, there may be some some shopping building where you can buy many shops now. It could be what the thing is right. That can be completely listed one, listed reference wise, or should be given at least so much I am going to expect. If you don't define, if engineer doesn't define what is to be performed, what is to be done by contractor, and then also writes a note in documents that it's contractor's responsibility to take into care all whatever you want contractor to do, specify clearly with reference to drawings and designs. Do not leave anything. This division of responsibility should be defined in matrix form. All items or major items are written there, heads are written there, and it should be written what is you can say in marks or in new tabs what is responsibility in this design or in revised design or what can do. Once you defined complete scope, it may cost you time, but there it shall reduce your disputes. Because you remember, you know that contract has to make money. Contractor must make money because the money is absent. Once scope is clear, it shall be easy for worker to and once the scope is clear, then contractor should not find any problem because drawings are given to contractor. If there is a problem with contractor to finalize scope and he cannot clearly understand, he can raise queries and get answer in time. But always there are problems, and there are people who are not sitting with contractor but they are somewhere else. They think contractor is corrupt. Just imagination in mind. Contractor, because he's a contractor, he has to do like that. We say sometimes like this, oh, he's a contractor, as if he's a thief, he's a channel. This is not right, Let me be shoes again. I tear my shoes because I have to go in 5 minutes. Life is really difficult, you can say, if your health is not good. It's really surprising. I used to walk very fast. I used to walk many kilometers a day, 6 kilometers average. I used to enjoy my evening, my afternoon by walking. And 12 September I broke that. 12 September 20 I broke that fortune, and I still am not able to regain that strength. Not even 20%. Really bad time. Sometimes life is like that. What to do? Life is that. You have to and beauty of engineering has gone because I am a civil engineer, and if I cannot walk, so what is meaning of being a civil engineer? Because walking is number one job you have to do. Walking is number one that engineer has to do. Standing is also very important, but everything is non my hands, and everything is also it's God who has to do and not myself. So I just come in few moments. Hold on please, just give me peace. And this is a problem with my it's getting off and off again and again. Why it's getting off, I don't know. Okay, dear friends, I'm back and I restart where I stopped. Oh my god, what to do? So, about contract I was talking, about scope of work I was talking. That is very important part, and we have to be clear about that, what we do, what we don't do, and that is very important that I have to understand. Very important it is. If you do not take care of scope of work, it may be contractor or it may be others, and the scope of responsibilities that employer has to take, contract can never be successful. It would go into disputes, and disputes are never welcome. And if design or complete documents that engineer prepares for contract, which are designated contract documents or tender documents, if engineer misses something, that is also not good. Engineer has no authority to miss something, because missing something means creating problems, and engineer's job is not to create problems but to solve problems. If intention of both parties are bad, means contractor and engineer or employer, all these three have different intentions. If employer thinks we will see in arbitration, if problems are raised, then engineer also thinks, a contractor also thinks that we'll check it in arbitration or court, then I think you are jeopardizing project from very beginning. This is not really, you can say, appreciative work. I can say that it's not appreciative. We should be plain, we should be clear about what we are going to do. That is very important. If you all time think that we'll see there and we'll see there, then you will keep seeing there, but project will see you. That's another point. Project, which is money, which is cost, if you want to see each other somewhere else, and you don't worry about your scope or your job responsibilities, and you always think I'll see there, and that's I think is nonsense. You should not see somewhere else somewhere. You have to see everyone on job. After all, this is your money, employer and contractor. This is also your job, your money. It is better to be clear beforehand, before working on project, before taking responsibilities, not to think of dispute-based earning money, but to think of work-based earning money. If you produce a project or do a project in 2 years, and you think that you want to go to arbitration because you did not tell something to engineer or employer which could lead to dispute, then I think this is not professional, and it applies same thing. It applies in similar way to engineer or to employer. If engineer takes this contract is very, very shrewd, if this contract doesn't listen to us, then we will do this way, then I think you're not the justice. You're doing justice to your profession, and you're doing the justice to public as well as to project. It's dirty thinking, and I think it's not available like this. People are honest, people are professional, people know their job, and such things should not happen, never happen, because nobody will get anything. All money, if there is a dispute, money to be paid to all shall be impacted upon. Employer shall hold money, and then contractor shall hold work, or contract by chance, by mistake overpaid, like this means engineer's fee shall be stopped. So all these points are dirty points if mind is not creative. Contract requires sound mind. Sound mind means logical mind, reasonable mind. If your mind is corrupted in beginning itself, you can't say that I am going to do this job. This job may be difficult for you. Principally speaking, jobs are never difficult if you keep sequence in your hands and your sequence are right. Job can never be difficult. Problem comes only when sequences are disrupted, and mentality thinks otherwise. Means my job is to create something, and I interfere myself in my job. I hold it here and I blackmail that man. But it's blackmailing. Everything is clear, but I quoted low. I want to make it more. As a contractor, this is not professional contractor if he thinks that way. Same thing to employer. If that employer wants more benefit out of that money, that is also not professional and engineer's fault. It is. Therefore, contractors should be based on equity, equal value to contractor and employer. Just and honorable dealing should be objective. No corruption in mind. No corrupt practices in mind. Everybody has defined jobs in scope. Everybody's price is fixed. This is paid to you or shall be paid to you for this work, or fees to you this work, and time is fixed. Time that is described in contract is very, very significant. If contract is not delivered in that time, it causes problem to everybody. Everybody, and that is immense problem, because time is time, contract is contract. If you don't value time, you don't value contract. This means first priority is time. Time is of essence in contract, because if time is not valued, it is not maintained, it is delayed, everything is jeopardized. Project is jeopardized. Project cannot come to operation, and returns to employer cannot come in, and payment of contractors can be held up, and payment to engineer can also be held up. So why to trap everybody into that disputed arena? Disputes are resolved by those people who do not know project, who do not understand project, particularly in our country. This is really unbecoming. If there is a lawyer or a judge who has to decide about that project, which is never assume or never even we can say think of, means what work is done, how work is done. If judge is there or advocate is there who doesn't know, who do not know what is engineering construction, how these processes move, they keep themselves within bounds of civil procedure courts, though it's not applicable in arbitration, but mentality cannot be changed. A project amounts to billions or trillions, or you can say millions, and these people charge a lot without knowing what work was supposed to be done. And engineer is expert on that. Engineer knows how we work in fields, but engineer doesn't come into picture because of system available here, because of abuse of system available here. So best solution is that engineer and contractor or employer should try to solve everything between and among themselves. Engineer is a kind of neutral body, neutral person, while engineer can help it, because ultimately impact shall come on to engineer also if arbitration is done against employer. Generally, employers are defeated in such cases because employers do not do their duties of providing money or of doing their other duties which they should do. Contractor has to make money, and contractor knows tricks by virtue of experience and by virtue of corrupt mind. Everybody's mind is corrupt to some percentages, we know. Everybody plays in its own expertise. Contractor plays in working expertise, while employer plays in investment opportunities, and like that everybody wants something. No employer wants to give extension on time because they say if extension is granted then my operation would be delayed, and no, you can say no employer wants to delay project delivery. But contractor says I need extension of time because of these reasons. Whatever reasons could be, not availability of money, or this not available, that not available, no resolution of this and that. There could be so many reasons for claiming extension of time. All these points creep up and you make big ball of disputes, which should be avoided. Because when you make disputes, you are going to spend more money on both parties' ends, and that money would go to pockets of adjudicators, and it would not benefit consumers to whom you are going to sell these product items, apartments or houses or shops or something else. Consumer would suffer, your economy would suffer. Therefore, it's better if you agree when disputes arise. You agree, okay, there is some way that some adjustment can be made somewhere. If that is possible, that should be made if both parties agree, because there is nothing illegal in that. Some tolerance is always available. But if both are honest, I think it's best. Honest doesn't mean you have to be Satyavadi Harishchandra. Honest means whatever you had to do, you should do. And whatever contract had to do, contract has to do, and that's it. Nobody is demanding that I have to go to moon, give me money. Nobody is demanding that. It is only contractual money, it is contractual work, it is contractual supervision that is required to be done, conducted. You are not doing any obligation on others. You are doing your job. You had to do. You are paid. You have to make me payment because I have done. Simple relation. Contract says I have to do this job, and contract says you have to pay me this much, and other party has to supervise it, and one more party has to audit it. There is nothing more than this. If you know all this, and everybody knows, that's also beauty. Everybody knows. You think contractors don't know? They know. You think employer doesn't know? Employer also knows. Because everybody is smart. And when everybody is smart, you know what happens? It is very difficult to select who is smarter or best one. You know, it's sometimes I laugh on saying that everybody is having well dressed. Everybody is just saying he's upgrade, he's very well educated and having high standard society. Yes, from dress you can see that. But when you go into depth and you find that this person has nothing with it, this person is neither very well educated, but his fashion practice is very high, he's very beautiful or handsome. She's very beautiful, handsome, and she's looking like as if she's very powerful, but when you dig out about her background or his background, you find nothing. So that is showroom beauty you want, or you want, makeup, or you want solidity. That is what is important. We know about contractor, we know about employer, we know about engineer, we know about audit party, all we know. Everybody has its own interest, and that should be purpose of party, purpose of profession. It's nothing that somebody is giving me free of something cost. I am doing service and I am getting that, that's it, and I am getting that service, I am paying him. That's only relation of contract, no other relation. So we should understand these relations in its reality. Why don't we understand that? Are we less qualified, or we don't have interpretation power? Why should somebody, you can say, educate for me? If employer and contractor start thinking that way, why is my money? Employer says, I am paying, is my person I appointed, this working for me, this engineer is working to just make sure whatever I am paying, that comes back. Only this is requirement. And for that there is a written document. That document describes everything. Then where is problem? Where is problem? Actually, there is no problem. Problem has been made by additional interest, by hidden interest, and that is where we should not accept. That's which not accept. Why we should accept that? So, my dear, to avoid dispute, because title of itself is dispute avoidance. If you see that last one, I said it was chapter number 21, that is after claims, that 20 employers and contractors claims, it was disputes and arbitration, and which says that there should be DAB, that is general conditions of disputes avoidance and education. So this DAB, dispute avoidance adjudication agreement. This is in disputes and arbitration, and constitution of DAB DAAB, failure to appoint DAB members, avoidance of disputes, obtaining DAB's decision, amicable settlement, arbitration, failure to comply with DAB's decision, no DAB in place. So that is what it says. When document itself mandates something, DAB is there, and it says avoidance, dispute avoidance, then we should be very smart to understand disputes are avoided. Why disputes are created, that's the point we have discussed. There is no relevance for disputes coming to appearance. Avoidance is important. And if we can avoid that, it's fine, we can avoid it. And if we can avoid this, we can enjoy. Means why do unnecessary waste time in arbitration, waste time in courts, calling lawyers, writing so much, answering so much, responding to so much? Because either engineer has to be very smart. If engineer is smart, I think there is no need of arbitration, because engineer is an independent official between employer and contractor. That's also true. And if engineer is swayed towards employer because employer pays, then in that case I won't accept that. Okay, employer is paying to everybody because budget is with him, but engineer has to think of self sometimes, self and others. It's easy to cause disputes. Disputes can be caused easily, but we don't want disputes. We want inputs rather than disputes. Why don't you believe in positive thinking? Why we don't delay everything and think that it's fine? I don't want that. I don't believe in wasting time. After all, engineer has no understanding of wasting time. No engineer believes in wasting time, because time is time. It's not in engineer's control. And why should we do inefficient work? Why don't we keep our contractor standard one and good one? Why don't we convince employer that do not be unfair to these people? And say, if work you are doing for people and you delay work, first you start very fast saying we will do this and we will break records, and then you may be fifth one, sixth one, seventh one or eighth one. These points we have to understand potentially. Very easy to fight, but why fight? What for? Why do you want to fight? Engineer has to realize this issue. Why should they fight? If there is a problem pertinent finances, they fight. come out of building and fight. This is not building issue. Well, we can only deliberate and liberate slavery mind. Those who have this always intention to raise disputes and get benefit out of that, those parties should not be respected, I can say, until there is willingness. If employer is not good, I don't like the employer. Very, very important point is that we have to deliver project. That's very important point. And if we can't deliver that project, what shall we do? Well, we'll talk it later on. The point was contracting, and contracting is we have defined. Contracting is not that easy as we think is easy. It's not easy. It's very problematic work because you have to deal with materials, human resources, machines, and what else is there. When we do project, we do it for public benefit. We do it for nation benefit. We don't do it just because we had to do it. And generally, paisa central roads. That is very important point. Public benefit. Public benefit should be of paramount importance. It can be private project, but somewhere it is dealt with public. No project is free of public. That point we have to keep in mind. And public means society. Benefit should go to society of suitability of project and efficiency in delivery. I have seen many projects which are not giving quality. Quality is very important criteria and should be forced if it's not done. I know that nobody would spoil quality, that is also true, but it is carelessness, it's ignorance, it's attitude, or you can say lack of knowledge. People have lack of knowledge. People have lack of knowledge of quality system. It doesn't mean if they provide bad quality they save something. No, it's not that. I don't agree with that. Previously it was thought that contractor is bad because contractor doesn't mix required quantity of cement into concrete. Concrete tries to save concrete. Contractor tries to save cement from concrete. This was thought and this was abusive actually. But this time we are getting something from suppliers, ready mix concrete, and that they are not going to change quantity of cement. So that was something which was actually very low profile corruption. Means particularly on government projects they don't bring full required cement quantity and play with that, and officially or formally they declared they got full quantity delivered. Now time has gone and definition of quality has changed. It is system now that quality system rules. It's quality system that works. It's not simple quantity. Quality system is different. We have to understand quality system. Quality is based on quality system. If, even though it's not defined in scope, there is a quality document, there is a safety document, system of quality must be implemented. What is system? Quality system is in demand. If you don't do quality, you won't get project. In fact, it's not only quality that you have to give added quality, added value to project. If you don't do added value to project, you may not get next project. That's also true. You may not get next project. That's also true if you don't give quality. Quality is a must. And since it is defined for respective contracts. I had worked out on NXSL in FIDIC, NXSL, and I had shared that document. I think documents are not shared, but explanation was given, and that will take later on how quality works, because step by step we are going in this. Now we are saying contracts, and what contracts are. Contract means contracts are contracts, parties are parties. We have to be very careful about this. It's not simply what we say is right, it's what system demands. If you do not understand this, we lose something. We have to lose something, and that something won't come out from somewhere else. It has to come out from our own. If I am unable to get quality through a contractor, I think then it's my mistake, my fault. I'm not capable to do that. Contractor would say, you are there, right? But contractor has also to ensure that it is his system, that he has to take care of that. The quality system that engineer cannot get implemented, then what for engineer is there? If engineer cannot implement or cannot force implement quality system through contractor, what is requirement of engineers? That's one question. If audit party cannot tell each other what's wrong, what's what? We have to understand this. Quality system is very important. If we fail in that, we fail everywhere. Every project has defined quality system, and it is duty of contractor, duty of engineer to make sure that the system. Quality system is not some, you can say, that cannot be understood very well. I have seen if I cannot understand quality system, because I have to audit that. If auditor cannot understand quality system, how shall they work? That's another question. You cannot simply say because I have done it. No, you have to comply with quality system. Even auditor has also his quality system, employer has quality system, engineer has quality system, everybody has their own quality system. Why then they cannot deal with contractors' quality system? This point is not zero. This point is good. You have to understand on this point. Why should quality be sacrificed? Why? I don't want to sacrifice quality. Means quality system has to work. It's not my system, it's approved system. It's not contract system but approved system. Means its contracts approved as well as engineers approved, as well as employers approved. It's engineer system approved by employer as well as employer's own system approved by. So they have their own systems and that must be respected. It may cost, it may not cost. That's not my criteria. My criteria is this is system that we have to follow, we should follow. So what's the problem with contractors? There is no problem with contractors. Problem is that contractor is also not going to gain anything out of this if system is not formed. Actually, nobody is going to gain anything. Yes, they may lose if they don't comply with that because of disputes, because of delays, because of misunderstanding, because of this and because of that. Life is easy, we say, but profession is not that easy. Profession is profession. Contracting is a profession. Engineer is a profession. We should realize this fact. If we ignore this fact, we ignore everything. A well-defined project can be spoiled if you do not keep up our statements. Contracting is very good business if it is done sincerely, and it's very bad business if it is done haphazardly. Haphazardly it cannot be done. With determination it can be done. Employer also has to do the same thing. Employer should sit all time and say, I have seen quality systems in many companies and they operate it properly. Yes, you have to work a little hard and those and others. You may be thinking why I am sitting like idle. This is also part of my quality system, to relax. Don't you think it's required? First of all, I want to sit idle. Second, I am thinking. And third is that patience is required. Patience is required in construction. Everybody does construction, doing construction, but doing with quality, both are different. See, we write our own systems. Important point is this. We write our own systems. Nobody writes for us. We may be contractor or whoever. We propose ourselves and we get it approved ourselves. Then we get it approved through engineer. We do everything for us. When something is done approved by yourself, what do you want actually? What's the problem you got in? What is your problem? Well, I think there should be no problem at all. There should be no problem at all. You are doing your job, I am doing my job. You are doing this job according to your own description, not my description. My description not imposed on you. Yes, I have checked that. I agree with that. That's my agreement is there. And if there was something I ask you correct, you corrected that one. So you should do that. But no, we are not. We are not doing that. Similarly, I can say there's another one, that is FIDIC Silver, which is having almost same type of chapters, and that's called EPC turnkey projects. Similar chapters are there, except that design is done by you can say contractors. It's called EPC contracting. And this we talked was a construction contract. Construction contract was. Got it, So we have to be very, very clear about this. Why I'm now, we have today covered something that's very, very useful, technically, contractually, and quality is very, very powerful. We have to think that way. Technically we are sound. Contractor is sound, welcome. That's what your qualification is, that was your requirement is. You are technically sound, you are efficient, you are powerful, and you take care of your responsibilities. So what else do you want? Why should we worry about them? If contractor does its job and we make sure that he improves in that, and if does, I think that there's no clash then. There should be no question on that. But it applies to employer also. Employer should also be fair. Employer should not say, I don't have money, I can't give you. I don't have money. Say, my bill you are not paying? Yeah, I don't have money. You hold on. You don't have money. Why did you start project? It is just, I am joking. There's a understanding, there's a clause that contractor has every right to raise to employer, give me your funding back. From where shall you get funding for this project? And if employer doesn't give satisfactory answer, in that case, a smart leader, books are there. Books, method books, quality books. technical books, contract books, all are there. But specific books are on project. You have to write methods for everything, for every work, every activity. You have to evolve your plans, safety plans, quality plans, work plans, or what else, supervision plans, though it is all included in there. You have to provide complete details of materials and drawings. All lists should be done in advance with your understanding of project. And you have to make sure that this what we are going to do shall be complied with fully, and if it's complied with fully, it is done fully, we can say. When this plan is there, you can say quality plan is there, which tells everyone what they have to do, who are people responsible. So you can say in case of something, some dispute, every question can be raised and dispute can be resolved at an earliest. Or we want to keep hanging, we can keep hanging. There is no separate problem. Best issue is do not enter into world of disputes. Think of your reputation as contractor, think of your reputation as employer, and think of your reputation as engineer, and think of your reputation as other party. Disputes help none. That is also true. Disputes help none. I say that. It won't help you, it won't help me. It will help to some other one who has no involvement in that project. So are we working for that, or we are working for us? We work on site, we work in field, we take risk, and somebody else come and to enjoy our hard work? No, it should not be there. It should not be there. Employer has good people with him, contractor has good people with him, and engineer, of course, engineer is engineer. So why should we move into that direction? So we should avoid it. Avoid it. Well, I think that's best possible answer. I can say avoidance of disputes, or you can say amicable settlement. If you cannot avoid, then you have to both come together and sit down and solve your problems, so that in future you avoid confrontation before others for sake of your money. If case is genuine, it can be solved, or if there's a corrupt mind behind, then I cannot say that somebody has calculated. If it's calculated dispute, even in that case, even your adjudicators or so-called arbitrators won't be able to help you. That's also true. That is also true. So we can say sufficiency of requirement must be used. Sufficiency of requirements. Contracts are based on sufficiency. Everything is based on sufficiency. And if you have sufficiency, you can do it. And if you don't have sufficiency, you cannot do it. Sufficiency of clauses, sufficiency of, you can say, provisions, sufficiency of, you can say, items, sufficiency of technical details, and you can say sufficiency of complete requirement that project would require. Now, I have just talked in very brief today, though it is more than 3 hours, but it's very brief because I am not still interested to go to 4 hours or 5 hours because of many reasons, and I'll see later. It's also cold also. My health is not that becoming. Now, we have talked of something very logical today. that is technical part of this, and how can we, what we consider about structure, how do we take building into our way, how we take planning into our way, and how we depend on drawings on standard drawing, on command that come back to us because of our work, and that how to accept that, how to use that, and how to understand, how to use, how to make, how to make details of staircase, and many other issues. We talk technically and we talk engineering wise. That's where it walks in. Contracting is something that is far beyond. That is, a kind of very reputed people, particularly in advanced countries. Contractors are given high value, because without contractor we cannot even survive. Contractors are experts of their field, means sometimes they are engineers in many cases. So engineers, if come into contracting, I think you should be happy that some qualified mind has come, qualified mind, but still reference is okay, I give reference, but what I think about, because those like Fiddick and like others who come into picture and they do something, some service to society, some service to the world that must be helpful, or that gives something to our people, to professionals, to contractors. Now Fiddick's contract form is very simple. In fact, it should be used. Though it should be used based on requirement, but analysis can be done. If you analyze this Fiddick itself, you may find many secrets, you may find many weak points, you may find many beneficial points, and you can improve them. That is your capacity. How you can design contract, how can you understand contract, and same thing contractor can do. Contractor can analyze it, engineer can analyze it, employer can analyze it, everybody can analyze it. There is no law that you cannot change in this. There is nothing that you can, it's mandatory, that's all right, it is mandatory, but mandate means what? Every person come and join. Can we do that? We'll talk later on when we come on to the titles of this. I am talking construction organization. This also organization, you can say contracts, communication and coordination, project quantity, like this, we'll keep talking together in coming days. We are talking something relevant, and one day I'll take this documentary or can share of document with you, and we'll browse only. When you won't be able to see myself on this video. The points are important, you won't be able to see. But no problem. We move like that. Life is that. We have to move like that. Life moves like this, so we have to move like that. No way out. Now, no problem. We have to think of how to make best use of, you can say, best use of plans. That is, I say, quality plans, or you can say site plans, or you can say project plans, safety plans, quality plans, management plans, manuals. IS 9000 has given you something, has removed something, has taken something. NXSL are there. I have done some work on that long back. We will see what was that, what is there in that, can it be amended. This type of talks will do. If you go to record of my videos, you will find so much. Though you are not going, I know. It's the FB, it's not YouTube, and YouTube, you can't share documents on YouTube, there is no provision as such. So there are various points that we should be worried about. Not exactly I can say. We should be worried about that, and that worry doesn't means what I'm saying is right or what you say is wrong. It's not that. Means it is professional analysis, is professional requirement. In my life, I consider analysis very important. If you analyze and then find solution, I think that's best approach. If you find solution just on without analysis, just simply okay, just do it in some arbitrary way, that's not good for someone. So we have to be little smarter this way. That's best approach, I can say, smarter. Now I think it's already 7:20. I should stop, and because already I have not taken my breakfast and I'm feeling little drowsy as also. No problem. We should be happy. It's only 3.5 hours today, and gradually I'll take more and more time. Is 7:20. I think it's better to close it down. So we have done good today. Of course, I'm not speaking very fast because I'm not well prepared actually, but I want to share my views with you. And if you want, you have some respect for profession, you want to improve your performance in field, you want to know, at least if you can't do it, it's also okay. It's also worth, if you can't do it but you want to do something, it's worth enough. It's quite you can say rewarding, rewarding. It's quite rewarding if you do that. So with this, I thanks a lot to everyone. I thank a lot to all my friends who either view or may view later on. And I think you should take some interest and do not worry about English because you think I am talking in English. It's not my problem actually. It is required because we are talking contracts, we are talking at international level. And Hindi we can talk, but it is very difficult to talk in Hindi. It's not very general talk, it's very professional talk, and I think it doesn't suit in every way. We have to be little realistic about this. I'm not speaking very difficult English, it's very normal English, and you all understand this much English. Even though you claim that you do not know English, I know this is false claim. Something everybody knows in English. So take it in that spirit. Language is not a barrier. A barrier is your mindset. This contracting talk is not a barrier. Barrier is your acceptance. You know contract, what is contract. Everybody knows, even you are not engineer, you know contract, meaning of contract. So why you think it's a barrier? Only point is that it's different field, that's all. Contract sense is same, it is contract act. We are in our country, and in every country there are contract acts, and they talk of that, they walk on that. That's what I'm doing here. So with this, I think now I have to go back home and go back to my and you also, maybe I know still you are sleeping, no problem, you keep sleeping. Sleeping is best answer. If you don't answer someone, just keep sleep. People will think, okay, we don't expect any answer from this guy. Don't wait, let him sleep. But okay, what can I say? Sleep is sleep. Sometimes I laugh for nothing, because laughing of two types, when shock laughing, and one is normal laughing, which when you enjoy something you laugh. When you enjoy your talk or something else, or some opinion comes to your mind, or some answer comes to your mind, then you smile. No, you laugh. This happens. So that is life. So I thought that you should not feel bored, or you should not feel something different. So did I. So I don't continue now. Sorry, gentlemen, it's enough. So I will move out from this part of talk, and then I can say Thank you very much, gentlemen. Thank you.